Hello, and welcome to the test review for sample test number 1. I'm going to work through the problems on this sample test and give the best explanation I can. So in this first problem, we're doing a distributive property. We're going to multiply 6x squared by the two terms that we have in the binomial in the parentheses. So we start off with 6x squared multiplied with 7x. So 6 times 7 is 42. And then the x squared is multiplied with the x, and since there's 3 x's there multiplied, we have x to the third. And that's going to be followed by a minus sign because we will have a positive times a negative number there. So we'll have a negative sign. 6 times 5 will be 30, and the x squared does not multiply with anything, so we just bring x squared down, and that is our answer for number 1. Problem 2 on this test is a binomial multiplication. Now I recognize that I have two conjugate binomials here, and by that I mean that the signs in the middle are opposites. And because of that, when you consider multiplying by FOIL method, the outside and inside terms are going to add up to 0 in this problem. And that is because these are identical with opposite signs in the middle. Those are called conjugates. So to get this answer quickly, we multiply 9x by 9x, and that's 81x squared. And then we multiply the positive 6 with the negative 6, and that is negative 36, and that is our answer there. Problem 2 is an addition problem of two monomials, but there's a problem here. We have terms that are not alike. X to the 6 and x squared are not like terms. You must not only have the same variable, but the same exponent on the variables. And because these are not the same, this is already simplified. There's nothing more that we can do with this problem. You do not want to do any factoring, because factoring is the opposite of simplifying. In problem 4, we do have like terms. They are both x to the 4th power. So all we need to do is to add the 5 and the 9 together, and that will be 14x to the 4th power. Note that we are keeping the exponents the same here because we're just adding up how many of these x to the 4ths we have. Problem 5 is what we call a binomial square. And when you have a binomial square, and we have two binomial square problems in 5 and 6. So I'm going to show one method in number 5 and a different method in number 6. In number 5, I am going to take the 9x minus 3, and I'm going to write that twice. And I'm doing this because squaring means to multiply something by itself. So now when I multiply this by FOIL method, I multiply the 9x's together, and that will be 81x squared. Then I multiply the 9x and the negative 3, and that will be negative 27x. So what I've done here is multiply 9x by 9x and 9x by negative 3. Now I'm going to multiply negative 3 by both of these terms. So negative 3 times 9x is another negative 27x. So notice that those terms are duplicates of one another. And then we multiply negative 3 with negative 3, and that is positive 9. Now, because we have like terms in the middle, they will add together, and so our final answer is 81x squared minus 54x plus 9. Now, it's important to note that when you have a binomial square, the middle terms here are duplicates of one another. And we're going to take advantage of that fact to do problem 6. When I see 9x plus 4 squared like this, my first term is going to be 9x times 9x. If you'll recall, that's what we did over here. Well, 9x times 9x will be 81x squared. Then we multiply 9x and the 4 to be 36x. But we are going to be doubling this because we are going to have identical terms. So 36x doubled will be 72x. And then positive 4 squared will be 4 times 4, and that will be a plus 16. So by doing it this way, we bypass the need to write down all of these steps. But you can only do that when you have binomial squares. Problem 7. We have a binomial multiplied with a trinomial, and this is true in both 7 and 8. So I'm going to start off by multiplying x by all 3 of these terms. So x gets multiplied by 3x squared, and that's 3x to the third. And x times negative 8x is negative 8x squared. X times negative 4 is negative 4x. So those are the multiplications involving the x. Now I'm going to multiply the negative 6 by all 3 of these terms, and that will give me a second row. And as I write this row, I'm going to write the like terms underneath the like terms in the top row. So negative 6 times 3x squared is negative 18x squared. So you've noticed I've written the x squares in the same column. Then negative 6 times negative 8x is positive 48x. And you'll notice that I'm writing that under the x term. Negative 6 times negative 4 is positive 24. And I write that in the back. There's no like terms for that to be added with. So now it's just a matter of adding up columns. So add together 3x to the third, but there's nothing to add with that. Add the x squared terms, that will be negative 26x squared. Add together the x terms, negative 4 plus 48 is positive 44x. And finally, we have a plus 24 on the end of this. And that's our answer. In number 8, we are doing the same kind of thing. We multiply x by all 3 of the terms in the trinomial. So x times 4x squared is 4x to the third. X times negative 3x is negative 3x squared. And x times negative 3 is negative 3x. Then we multiply negative 5 by all 3 terms. So negative 5 times 4x squared is a negative 20x squared. And again, I'm writing this under the x squared term. Negative 5 times negative 3x is positive 15x. And negative 5 times positive 3 is positive 15. Again, we're going to add our columns together, and we have 4x to the third minus 23x squared plus 12x plus 15. So that will be for the front side of this sample test. And now we're over to the back side, which is factoring. So in this first problem, and with all of these factoring problems, we want to factor out common factors first. In this, sorry about that. In this problem, there is a common factor of 2. So we're going to take the 2 out, and we're going to divide each of these terms by 2. So that's going to give us 5x squared minus 2x minus 6. Now we would ordinarily look at that parentheses and see if we can factor any further, but since we haven't talked about trinomials as of yet, we're going to leave it like that. In number 10, we have 49x squared minus 9. There are no common factors as I can see, so I'm going to proceed to my next step, which is identifying the type. This is a difference of two squares, and that's always the first type I'm looking for when it's a binomial. So since it's a difference of two squares, I'm going to do a square root of the 49x squared, which will be 7x, and I write that at the start of each parentheses. And the square root of the 9 is a 3, which I write at the end of each of these. And I put plus minus in the middle. So the factors are conjugates because that's the only way to get this binomial with these middle terms disappearing. Problem 11. We have a common factor. Again, we always want to look for common factors first. There's a common factor of 2 that's going to be divided out of this. So that's going to go in front of parentheses. And when we divide by 2, we get 27x to the third plus y to the third. So we then look at the parentheses and make sure there's no common factors left, which there are not. So then we proceed to try to factor this. We first look to see if it's a difference of two squares, and it's obviously not that because there is a plus sign in the middle. But I also note that I have a lot of perfect cubes here. In fact, everything in here is a perfect cube. And so this is a cube type. So we're going to have a binomial multiplied with a trinomial. So we're going to start by determining the binomial factor. We do this by doing a cube root of the two terms. The cube root of 27 is 3. The cube root of x to the third is x. The cube root of y to the third is y. And I put a plus sign in the middle since there is a plus sign there. The first sign is always the same as in the cube type. Then for the trinomial, we take the 3x and we square that, and that will be 9x squared. And then there is an opposite sign from whatever we have in the first parentheses. Then for the middle term, we multiply the 3x and the y, and that is 3xy. And then finally, the last term is always positive, and the last term is squaring this term up here. So when we square the y, we get y squared. I'm going to squeeze that in there. So those are our factors for number 11. In number 12, just like all these problems, we're going to look for a common factor. The common factor that we can take out of these terms will first involve a 2 and also an x. So when we divide by the 2x, the 2x will be in front of the parentheses, and the first fraction will leave us with a 4x squared minus 15x minus 6. And I look at this trinomial and I don't see any other common factors that can be taken out. And just like number 9, it's a trinomial and we don't know how to factor that yet. So we're going to leave this as it is. Number 13, common factor of 5. You take out that common factor of 5 and we are left with x to the third minus 8. Excuse me again. So x to the third minus 8. We first look to see if it's a difference of two squares, which it is not. But I notice that it's a cube type. So we're going to do a lot like what we did with number 11. and we're going to do cube roots. A cube root of x to the third is x. A cube root of 8 is 2. And I have a minus in the middle because it was a minus in the original problem. Then we're going to have the trinomial. So the first term is squaring the x, so that's x squared. Then we have the opposite sign, which is a plus. Then we multiply these terms together, and we have a 2x. Then you square the negative 2, and we get positive 4. The last term is always positive in this. Number 14, common factors. I noticed that a 5 is a common factor here, and also an x will be with that. So 5x is the common factor. What's left over will be x squared minus 9. And I'm not going to mess around with this very much. X squared minus 9 is a difference of 2 squares. And the factors are x plus 3 and x minus 3. Now, the x's come from the square root of x squared, and the 3's come from the square root of 9. And there's opposite signs in the middle. Number 15, at a quick glance, looks a lot like number 14. There is a common factor of 5, and when I take out that 5, I'm left with x squared minus 4. X squared minus 4 is a difference of 2 squares, with the factors being x plus 2 and x minus 2. And finally, number 16. We have a common factor of 8. Remember, you always have common factoring as your first step. So we take out an 8, and we are left with x to the third plus 1. X to the third plus 1 is a cube type. It's not a difference of 2 squares, so make sure it's not a difference of 2 squares before you go to the cube type. Since it's a cube type, I'm going to do a cube root of x to the third, which is x, a cube root of 1, which is 1, and there's a plus sign in the middle of those terms. And then we square the x, and that's x squared. We have an opposite sign, which is a minus. We multiply x and 1, and that's x. And then we square the 1. 1 times 1 is positive 1, and that will be